Hello friends, welcome back to the channel. Here again bringing you another Sunday video. Haven't done this for, I skipped the previous week, but now I'm back. And in today's video I thought of doing, well, a little bit of everything really. I wanted to talk about CoW protocol. I also wanted to, as I go through this protocol, talk or think out loud. What am I thinking about, like what metrics to analyze, how I would go about solving some things, and also some tips and tricks on when you're using the some of the tables in EVM. So let's get right into it. So if you haven't heard, CoW protocol is like I would say it is an aggregator, and it is an intent based aggregator. So you tell, basically what that means is you tell the protocol what you want, like you want to swap WEF for whatever token, and then what happens is CoW protocol would sort of batch some orders, so several orders together, and then a group of people or team called solvers would try to, is it solvers? Would try to find the best would try to find the best route for your swap. So let's say you want to swap from WEF to, I don't know, CoW or like USDC, and given the amount and given slippage and whatever, they'll try to find swap routes that best fits what you want, right? So that's the overview of CoW swap or CoW protocol. And I did take a peek at their docs. Very handy docs, by the way. So there's like a settlement contract where the trades actually happen, and then there's like this relay contract. So I think if I understand this correctly, right, what happens when you connect your wallet and you do the swap is it sends off, you're signing basically a message that says, okay, I authorize the protocol to take this amount of WEF and then do their own thing in a separate transaction, and then once they've done their swap, send it back to me. So essentially that's what this relayer is, having those allowances. And then the settlement contract is where the actual solver would post their settlement trades. So pretty simple, right? Very straightforward. And then I also found another one called ETH Flow, and I was reading through this, and essentially what this means is that because you cannot sort of like you cannot take ETH out, and also since it relies on USD20, there is an additional contract called ETH Flow where you sort of sign, not sign, but you post a transaction stating your intent with your ETH. And I actually stumbled upon that transaction here. So what I did was I went to ETH Flow. So in the docs they all tell the contract address. I forgot how I found the ETH one, but essentially here it is, right? Essentially what's happening here is this person wants to swap their ETH, not WEF, for something, and so they are signing they're creating a transaction stating their intent, and yeah, it's creating an order, and essentially when this order gets passed into the solvers, they will be able to take the ETH that was sent to this contract and then change it to WEF, and then from that swap to whatever tokens this person wanted to swap. And also very coincidentally, when I click on this address, I was able to find the corresponding transaction where they received the swapped asset. So this, you can see here, it's 143, and then in this transaction 145. So after this person submitted their order, 2 blocks later, they received the swapped token, and we can verify that by looking at the ERC20's sent, and this person is EC4, and that's his address over here, or that's their address over here. So they stated the intent, yeah, this amount of Neuro tokens, and looks like they received slightly more. Interesting. Yeah, okay. Not sure how that works, but yeah, they received slightly more Neuro tokens. Yeah, so yeah, we'll take a look at this. I already did take a look, and what I was trying to find out is like I was trying to find out what events are emitted from the CoW protocol. So I just looked at Etherscan, go to logs, and just scroll. And the first thing I see is that from the settlement address, it emits this event called trade. Okay, and then if I just do a Control F for trade, looks like there are 4 results of trades, which means in this particular transaction, the solver sort of does the swap for for 4 intents, right? Basically, there are 4 different people wanted to swap, 4 different things, and in this one particular transaction, the solver managed to do all the solving, all 4 solving in this transaction, and all those intent is recorded here, right? Where the sell token and then the buy token. So you're swapping. This is WEF. You're swapping WEF for whatever this token is, and then you're sending it back to whoever created the order. And then the other quirk I found out is that because of this ETH flow, which again takes in only ETH, enables people to swap from ETH without swapping to WEF first. The owner is the address. So you can see the contract address is 40A, right? And here the owner is 40A. So that means what's happening is that the settlement sends the resulting swapped token back to the ETH flow contract, right over here, right? His owner, and then somewhere in the transaction, the ETH flow contract will send it back to the original owner. So if we go back to our here, we can see that it looks like the settlement itself contract, not the ETH flow, send the tokens back to the owner. So I guess we cannot rely on the owner here when it comes to ETH flow. So yeah, so the first thing that comes to my mind is like we need to find out like how do we tie ETH related swaps back to the original owner. And so I was trying to find like what is being emitted here, and the best way to get a quick look is of course blocksec. If you watch my other videos, you would know I use this pretty often, right? It is a explorer that is mainly used for looking at traces. So in this traces tab, I usually like to click all, and this would expand every single trace. And you can see that this is the event that's emitted, and this is the trace call this is a trace call that happened, which emits this event. So I was looking through what information is emitted, right? Not that Nothing that seems to be like a identifier, except in traces, in this trace call, there is something called order hash. And the term itself, order hash, already sounds like a potential identifier, right? So what I did is I just copied this thing. I try to find if order hash appears here, right? I get no results, but then I remove the 0x in front, and I get one result. It's a matching result, and it seems like the order UID that is emitted in the settlement event under the trade event name, the first 64 characters is the order hash that we got from the trace. Okay, so that's a way to connect traces with event logs, right? That's an identifier you can use. Now, one thing to do is first you have to verify if this identifier is really unique. So doing something like get the order hash and then count one, group by the order hash having the count one more than one. If that returns 0, or if that returns null or no results, that means this is indeed unique and can be used to join in with this order UID over here. Now, why do we want to join in? I guess the reason why we want to join is mainly to get who is the original sender, right? In this case, it is this address over here, right? So that's the reason. Okay, so yeah, that's where we're at currently, right? And then I'm also thinking, okay, so since this event emits trade, I can then already do a couple of things. One, I can look at how many intents or how many trades does a solver take on average per transaction. Okay, now the solver will be this address over here, and then you will just count the number of event logs where the trade event is emitted. In this case, it's 4, right? It's 4, and then you can sort of do further analysis. For example, this will be a very big simplification, but since the solver paid this amount of transaction fees, you can also calculate the average transaction fee per swap, and yeah, maybe that could be a comparison you can do, like if someone were to swap on Uniswap versus having the solver do it for them, how much gas savings do they can they have, right, basically. And yeah, maybe I'll roughly go through how do you count this. So I already have a query here, but I'm gonna make a new query just to show some stuff. So first thing we want is I'm gonna use both the event logs and decoder event logs table. So let's start with the event logs table. Now I'm gonna here's where I wanna tell give a tip where I see a lot of people make the mistake of, right? So first thing I want to do is I want to get just this transaction, and then the date I think is sometime in November, so something like this. And now the important thing about event logs, right? The unique identifier for event logs is, first you want a contract address. Oops. And the contract address here would be this address over here. So contract address is this, and if it's in capital, just add the lower function, right? And after you add contract address, this by itself is not unique. You will need an additional filter called topics. In this case, it is topics 0. Oops. And the combination of contract address and topics is your identifier. Now, the mistake that I see a lot of people make is they use origin function signature, and then they do like an origin to address equals to or from address, right? Now, this is wrong. This is outright wrong, and um, the reason for that is because origin function signature is just the original function signature that someone sent in the transaction. In this case, it's this over here. Is this 0x13d979ab or 0b, right? And this isn't even the full version. Like, there is a longer version of this, and then because it is the function signature, it truncates to the first 4 bytes, which is equals to 8 characters. And you can see why it being truncated loses its uniqueness property, right? And so this is wrong. Using this alone is wrong, or using this solely is wrong, unless your intent is to only look at this particular function sig for some reason. Then I think that's the only case I can think of where you would use this filter. The other filter I see people use is origin to address alongside with origin function signature. Now, in this particular case, maybe all the settlements has to be directed to this address first. But you can imagine if I am swapping on, let's say, this particular Uniswap pool, Uniswap pool, right? You can already see this as an example where the origin to address is not the Uniswap pool. It is another contract address, which is here. And so in theory, if you're just looking at swaps from the Uniswap v3 pool at this particular pool, and then if you filter for origin to address being this one, then you've already missed out on a lot of transactions. So using these two filters most of the time is wrong, and you should just completely ignore them. Now, when is it a good use? When is it a good time to use these filters? For example, if you want to look at transactions where people specifically interacted with the MetaMask swap feature, for example. Now that is I would say like the best use case for looking at for using origin to address, right? You want to get all the addresses where people specifically interact with the MetaMask swap UI, and that has a fixed origin to address. And if that is your use case, then you will be right in using this filter. If it's not, then just forget it. Other times I'll see people using like contract address and also combination of function sig and origin to address without using topics. And yeah, this is just wrong, right? Now, the reason why these two is a combination of these two is unique is because in the contract, when you write a contract and when you write the events that are emitted in a given contract, let's say event name is I don't know, transfer, right? When how the topic 0 is created is basically they apply this kcac256 hash on your event name plus all of the data types. So like UIN, address, something like this, right? Or is it the other way around? Now a kcac hash of this returns you the topic 0. And if you have the same after hashing, if you have the same topic 0, you will not be able to compile basically. And so that's why topic 0 is unique with respect to having the contract address. So in the given contract address, all topic 0 are unique. In the same rationale, in a given contract, all input function sig for a given function is unique as well for this exact same reasoning. Now that I think about it, can it be duplicated? Likely not. But usually what happens is you would do something like this, right? You just grab the first 10 characters of the input, and if this trace index is 0, this is the origin function's nature. Fun fact. But if it's not, it's just the it refers to the function, or it's an identifier for the function in a given contract. Okay, enough rant. Where was I? I am looking at the number of trades, so this would be, yeah, this would just give me the number of trades in that transaction. I'm expecting four rows. There you go. So 4 rows, which means there indeed were 4 trades, 4 intents being solved in this transaction itself. Okay, so there's event logs, and you can, if you use decoded event logs, it would just be contract address, contract address plus event name, and yeah, that's the identifier. Okay, let's go back to my previous query. What did I do, right? So first, I used the event logs table to look at the order placement event, which is this one, right? This big chunk over here. Decoded event logs table, we already have it decoded, so all this comes in nicely as a JSON column, and so it's you can query it like this, right? Very straightforward. And then I also looked at the order hash. So remember when I looked at the where is the falcon? Here, where the order hash is emitted in outputs in traces, and so this CTE is basically getting the order hash. Now I didn't complete this because I found out, as I explained, the order hash is already present here, right? And because I know the owner is, if the owner is this, it will mean that the original token, the cell token, is ETH, right? Yeah, that is already enough information for me. I don't need to then join the two together. So when I just went ahead and did I used the event logs table for the trade event, right? Or for all this trade event, get all of the, what is the buy amount, what is the buy token, sell amount, sell token, and then of course grab the prices table and join with the prices table. This is just a SQL thing, but I see a lot of people sort of like try to join everything in one CTE. You are free to make multiple CTEs. In fact, it makes it even neater. It makes your code neat, right? And the reason why I'm joining prices 2 times is because the first time I want to join on the buy, right? The buy token needs to have a buy symbol. I need to know the decimal. I need to know the price. The second time I'm joining the prices is for the sell, right? The sell token. Again, I need a sell decimal, I need a sell price, sell symbol, right? This pattern of joining prices is very common when it comes to dexes, where there are 2 variables that you want to get. For if you're doing NFT stuff, you only join prices once, because there's only one currency. Same thing goes for like most of the lending stuff. There's only one currency at play at each time. Okay, and then what I've got from this is that I was trying out this thing, like I concatenated the swap from what to what, so then I got I have a new column that looks like this where it says, so, WEF to USDC, how many transactions and what's the volume. Another small rant, I see a lot of people doing volume where they do buy USD plus sell USD divided by 2, right? Now the intention is there, but there are cases where sell USD is 0. And so what happens when sell USD is 0? Your volume is now halved, right? It's halved. And so I think a better way is just to use coalesce, right? If buy USD is null, use sell USD, and that's what coalesce does. If you want to take it even further, you can just add like coalesce buy USD. You can just add like, if all this is null, just put it 0, but that's not necessary. And then from this I can see what are the, in the past, what's this, since November I think, right, in the past month, which trade routes of which intent are the most popular by volume and by number of transactions. Yeah. And then you can do more analysis on this, right? Like, for example, you can think of like what tokens are being sold or bought via CoW, right? Like, what is the advantage of this versus what's the advantage of this versus swapping on Uniswap directly? And maybe you can think of this in terms of gas price, transaction fees, right? Right. Think about this solver being able to solve all this, and you having only to pay transaction fees for this if you're coming from ETH, right? So definitely some savings on transaction fees. You can do this comparison. You can also look at what are the types of users that are using CoW protocol. Like, for example, in terms of volume, like, is there a certain threshold, right? Mostly are the swap volumes mostly coming from people who have high volume that they want to swap, or are they the same on average as a regular Uniswap swap? You can also think about like loyalty. Maybe a harder thing to measure, but how I would do is like you take a slice, so get all addresses who use CoW swap or CoW protocol in, let's say, January, right, of this year, and then look again in the mid-year mark, right, in, let's say, June 2024 onwards. How many of them use exclusively CoW, or use others as well? I imagine you get maybe a more inconclusive answer here. Maybe it's more others as well, but who knows, right? And these are the type of questions that you will not see people doing because it is slightly more complicated, and you have an edge here, right, to look at these stuff topics. Right, instead of just looking at volume all day, why not take a look at more into behavior, right? Who are the people actually using the protocol? What is their intent? No pun intended. What is their behavior, right? Look at their loyalty, look at their retention. Behavior could be in terms of volume, it could be in terms of the types of token, right? Types of tokens being swapped. All these different factors. And I think that is it. Really just want to call out a few things, some tips and tricks from earlier. Also want to share how I was thinking about analyzing this protocol, right? Hopefully that's helpful. Another thing I want to introduce before I go off is we have a new query referencing. So imagine this is your base query that you want to do more analysis on, right? Based on your based on the results of this query. So I'll just copy this uh, whatever this is, right? And this is my query ID. And then let's say I make a new query. I can then select from, and then I believe the syntax is like this. Yeah, there you go. So $ query, and then in brackets paste your ID, right? Now a bug I noticed is that the words are in white against a white background, but you can just do like this. Now the cool thing about this is that this runs really fast, so hopefully I'm not jinxing it by saying that. But it runs the results very fast, right? So previously you would have to do like live query, the previous query, and then flatten it. Now you don't, right? All this is here. So I can do something like select all from this where, let's say, volume USD more than like 10 million. 1, 2, 3, 1, 2, 3. Is that 10 million? Yeah, okay. Yeah, so the benefit of this is you don't have to rerun your query. You can just run a query based on the results of an existing base query. Now there are some limitations to this, like I forgot what is the something like 30 days. It's capped for 30 days from when it is last ran, so you can just run the base query again to get it refreshed. But yeah, just wanted to introduce this new query referencing feature that the team introduced. Alright, awesome. So takeaways from this: use contract address and event name for the decoder table, or contract address from and topics 0. Remove all of that origin function crap, right? Just take it off. And then yeah, if there is one takeaway, I hope that is your takeaway. And I think that's it from me. Yeah, let me know what other topics that you guys want to learn more of, and I'll catch you next time. Bye.